Hey, space travelers! Here is an exciting free update to a critically acclaimed Space VFX video course for Blender by Aidy, Burrows and me, Gleb, Alexandrov. After watching this tutorials, you'll be ready to take your space art to the next level, because we'll be talking about Micropolygon Displacement, very awesome feature, and more. And basically there are different names for that feature: Micropolygon Displacement or rendering, Adaptive Subdivision, and Tessellation. And basically these three things are completely interchangeable. Alright, so this tutorial is divided in two parts. This is part 1. Keep watching. Okay, so we're gonna start with Micropolygon Displacement Basics, like a quick introduction. Then we're gonna explore the terrain height maps and the procedural terrain using the displacement. After that, we'll take a look at generative modeling using displacement and some procedural noises. And another way to use displacement that we'll explore in this tutorial is adding the surface details, which is perhaps one of the most popular things people do using displacement. And finally, we'll talk a bit about optimizing memory usage, because displacement can crush your computer. Okay, so let's get started with the Micropolygon Displacement Basics. It's kind of an introductory look into this technique, so later on we could move on to the beef. Let's get started by adding a cube, of course, and setting the feature set of cycles to experimental, because right now the adaptive displacement feature is available only in the experimental set. And now I'm gonna come down to the performance tab and set the start resolution to 512. This will make the viewport more responsive during the updates. And now I created the new material and called it displacement. And obviously, to be able to preview our displacement, we have to switch to the rendered viewport mode. That's what I did here. And let's go over to the environment tab. And just for the sake of making a beautiful picture, let's create the sky texture. Let's set the strength to maybe 3. Okay, technically this doesn't relate to displacement, but it's like our cube is floating in the sky. It's nice. And now I come over to the material settings, and we can change the displacement type to bump, true, or both. In a moment I will explain what it means. Let's switch to the node editor. Press Shift A, select texture, noise texture, and right away I'm gonna plug it into the displacement socket. As you see, the effect is quite subtle and our displacement mode is bump. So what I'm gonna do here first is add the converter math node, insert it over here and set it to multiply mode. And let's increase the value and see how it affects the bump. Technically it just makes it appear stronger. Now let's increase the amount of details, set it to 5. And the next thing that we can do is just switch to the true displacement mode. And we see nothing. Congrats! Because we have not enough geometry to displace. We have to subdivide the cube to create the source material for the displacement, so to speak. Let's go to the Materials tab. What we can do is just add the subdivision surface modifier and increase the amount of subdivision levels. I'm gonna press Shift Z to enter the rendered viewport mode. I'm slowly increasing the number of subdivision levels, and now we can see how the procedural noise texture is displacing the geometry. And take a note that we don't use the adaptive subdivision yet. Alright, let's switch it back to the bump mode, and to refresh the viewport, press Tab 2 times while hovering the mouse cursor over the viewport, and you can switch it back to true, hit Tab 2 times, or alternatively you can set it to both. This setting is kind of self-explanatory. It will use the true displacement as well as the fake bump. For now I'm gonna set it back to true, because I will be controlling the bump separately. And let's switch to the node editor and add converter math node and set it to subtract mode. We need this node to balance the inflation that multiply node causes. I set it to 2.5 because that's roughly the half of the multiply value. Halving the value usually works pretty well for some reason. And by pressing Tab 2 times you can refresh the viewport, and now you see that the displacement no longer balloons the object. It maintains the volume of the initial object. Alright, awesome. What I'm going to do next is demonstrate how adaptive subdivision works. So I'm gonna move these nodes over here and press Shift A, go shader, mix shader. Also I'm gonna add the emission shader. Shift A, shader, emission. Drag it into the second socket. But before, let's add the wireframe node and connect it to the mix factor. And this one goes into the second socket of the shader. And now we can see the wireframe. Let's shrink the pixel size, set it to 0.002. Look, as we are moving camera closer to the object, we don't see that the polygon changed their size, and that's normal behavior for the subdivision surface modifier. But that's not efficient by any means, because when we are far away from the object, the polygon size becomes too small, and vice versa. So I'm gonna add the array modifier to demonstrate this concept, and let's set the count to something like, I don't know, 50. And let's position camera this way so these balls converge into horizon line. Oh, and one more thing, let's move the array modifier to the top of the stack by pressing this button. And now we can enable adaptive subdivision. And watch this, after we enable this checkbox, the amount of subdivisions on the object is calculated based on the distance from the camera. So the farther away object is from the camera, the less subdivisions it will have. Once again, to recalculate the subdivisions, you can select the object and hit Tab 2 times. Like this, Tab, and then Tab. And it recalculates. Isn't that ingenious? So this adaptive subdivision thing is really the way to optimize the displacement based on the distance from the camera, and thus the pixel size. In the subsurf modifier, you have this dice in scale parameter. It's kind of counterintuitive, but the higher this parameter gets, the less subdivision levels will be applied to this object during the render. For example, if we set it to 2, it means that this object will be subdivided 2 times less than if it was set to 1. And in the render tab, we have this subdivision rate global settings. Right now in the preview, we have 8 pixels. We can set it to 4 pixels to up the resolution of the subdivision. We can even set it to 2 to effectively double the amount of polygons. And this max subdivision parameter obviously controls the maximum number of subdivisions. Let's set it to 8. So right now the preview is set to 2 pixels and the render to 1. Let's unify it. Let's set 1 in the both tabs. That means that the size of the polygon will equal the size of the pixel. I'm going to select the mix shader and press M to disable the wireframe rendering. And one more thing that I really want to show is bump. How we can control bump separately from the displacement. Let's press Shift A, select vector bump, drop it over here, and connect the output of the displacement to the height input of the bump node. And this node should go here in the normal input of the diffuse shader. And now you can manipulate the strength. And by setting the distance and the strength higher or lower, you can control basically the bump separately from the displacement, which is very handy, of course. And you can press M to disable the bump node and enable it back to preview the effect of the bump. Okay, now if we press Z to enter the wireframe rendering mode, we'll notice that our cube is still subdivided. That's because in the subdivision surface settings, we have changed the levels, but if we have activated the adaptive checkbox, this thing doesn't influence anything, because the subdivision is calculated during the render based on the dicing scale. Okay folks, now let's explore 4 awesome ways of using displacement in Blender. And the way number 1 which comes to my mind is terrain height maps. We have a plane here. Let's hit Tab to enter the edit mode, then press U and select Unwrap. That will unwrap the plane. Simply unbelievable. And now let's go to the Materials tab, click on New button, and let's call the material Displacement. I'm pressing Shift A, selecting Texture, Image Texture, and clicking on the Open button. I have 2 textures in this folder. First one is the terrain height map exported from World Machine. And the second one is just a color map. World Machine is amazing software to create landscapes as well as exporting various maps like a height map. It's paid, but it has a free version if you want to try it. Okay, so I'm gonna select this terrain height map, click on Open, and right away I'm gonna drag the color output into the displacement input. I'm pressing Shift Z to enable the real-time viewport. And to preview any particular node in the node editor, you can hold Ctrl Shift and click on this node. But you should have the node Wrangler add-on enabled to do that. Okay, and I'm gonna click on the diffuse node to bring back the preview of the diffuse shader. And in the modifiers tab, I'm gonna add the subdivision surface, just like we did in the previous section of this tutorial. Let's also don't forget to enable the adaptive checkbox. And what else should we do? Right, in the materials tab, we should enable the true displacement method instead of the bump. Now we are ready to do some fancy displacement. Let's just add the math node right after the image texture, set it to multiply, and I'm gonna click on this value and type 5. Oh, it's too low, let's type 55 and hit tab 2 times to refresh the visualization of the displacement. And now we see gorgeous mountain. And you know what? I'm so excited about World Machine, about Blender, about coffee. Let's add the math node, set it to subtract, and type something like 22.5. Once again, that's a half of the value in the multiply node. But I think in case of this mountain, we can set it lower. Basically, I'm doing it to align the base of the mountain, so to speak, with the plane position and make the displacement work outwards. In the render settings, we can experiment with the subdivision rate. For example, we can try setting it a bit lower, like 2 pixels. Or if you want faster previews and faster calculation, you can set it to 8. But I'm fine with 3 pixels or 2 pixels because it's detailed enough for me. It's a compromise between quality and render time. Alright, now I'm adding yet another image texture. Click Open, navigate to Textures folder, and this time I'm gonna pick Terrain Color. And unsurprisingly, drag it into the color slot of the diffuse shader, and now we see super beautiful mountain. Isn't that impressive? That we took just one polygon and we displaced the whole thing out of this polygon. Micro displacement really rocks, especially when coupled with a good diffuse texture. And the last thing I'm gonna do is add the bump node, connect it over here. As you've noticed, I didn't use the grayscale height map, I used the color map instead. The reason behind this is that I want to add the small scale bump to the snow, as opposed to the large scale details of the terrain height map. Before moving on to the next step, I would like to disable the diffuse color by holding Shift and dragging across this line. That will allow us to preview just the bump. Here's a quick comparison between the no bump version, the bump strength set to 0.5, and finally the bump strength set to 1. So I decided to use the color map to generate the bump map, but perhaps the best practice would be to use the height map. So let's plug it into the height input of the bump. Right now we barely see anything, because we have to increase the strength or the distance of the bump. Let's try setting the strength to 10, or maybe even to 20. And you can see that it doesn't help so much. Let's bring it back to 1, and modify the distance instead. Let's set it to 2, maybe crank it up to 3. I would even try 6 and see how it looks. And it looks just alright. So if you feed the height information into the bump node, it really allows you to compensate for the lack of the details in the displacement, especially if the subdivision rate is set to a higher value like 3. Alright, so the idea is that you can get away with the higher subdivision rate, like 3 pixels, and bring the details back using the bump map with the terrain height map used as an input. But as I've mentioned before, I have another kind of plan. I'm going to use the lower subdivision rate for the displacement, and that means the higher quality. So probably we won't need to plug the height map into the bump. We are going to implement the finer details instead. So let's hook it up to the height. And let's also set the distance back to 0.1, because 6 was way too bumpy. Alright guys, let's drag the color back to the diffuse shader and keep on talking. Also, we can try inverting the bump and see if it somehow looks better. In this particular case, I think that the inverted bump creates sharper details. Of course, from the logical standpoint, it's a little bit weird that the snow looks indented. But on the other hand, I love the visual sharpness of this effect, so I'll leave it inverted. So the plan is to keep the subdivision rate sufficiently low. Let's set it to 1, and that will give us a lot of geometry to work with, a lot of polygons and a lot of video memory used. We'll talk about that in a moment, but for now let's try making a render. So let's come over to the render tab, set the resolution. Right now it's set to 1920 by 1080 pixels. Oh my goodness, the subdivision rate is set to 1 pixel and the resolution is pretty high. That may be problematic. We'll see about that. Ultimately, it depends on your video card. Now I'm pressing 0 on the numpad to enter the camera view and Shift F to enter the first person mode, and I'm using WASD keys like in first person shooter to navigate the camera and pressing render button. It renders super fast actually, and we get this, which is gorgeous, and it apparently took a gigabyte of video memory. Let's double the resolution and see what happens, because the double resolution will mean 4 times more pixels. So I'm typing in 200%. Let's now hit render and wait for inevitable. Let's wait while it calculates all this stuff, normals, and bam, we have an error here. It says CUDA error out of memory. That means that we're doomed. Oh, actually we aren't. We can set the subdivision rate higher, to 3 pixels for example, and that will save us some video memory. In the end, you make this decision whether to use 1 or 2 pixels for the subdivision rate, based on many different things, namely the resolution, the available video memory, and what part of the screen the object occupies. But be careful to not burn your computer. Okay, so by using the height maps exported from World Machine, Terragen, View or other software, we can get these amazing results by using the micro displacement feature of Blender. And look at this planet in the background. It's the planet from chapter 2 of Space VFX. See, everything looks better with the planet. And the cool thing number 2 that we can do using the adaptive displacement is procedural terrain. Once again, let's get started by creating a plane. And now let's come over to the materials tab. Add new material. I like to rename stuff, so I called it displacement. In the node editor, let's hit Shift A to create new texture, noise texture. Drop it over here and connect it to the displacement socket. I'm repeating some steps that we need to do to actually activate the true displacement, so set the displacement method to true. Now let's switch to the rendered mode so we can actually see the displacement. And finally, of course, let's open the modifiers tab and hit add modifier, add subdivision surface. Let's switch it to the simple mode, so it won't smooth out the geometry, it will just add polygons, and hit adaptive. Now we are good to go, we can start playing with the displacement texture, so let's add the math node. Click here and select multiply. And let's put some value in here, like 5. Now we can press tab 2 times to refresh the displacement in the viewport. Okay, let's make it even stronger, let's set it to 7. And let's add yet another math node, select subtract, and set it to the half of the multiply value, so let it be 3.5. Now if we compare the position of the plane before and after the displacement, we'll notice that the plane stays roughly at the same position. See, no shenanigans happen whatsoever. It's very predictable. It's kind of good. Okay, let's add the color ramp node and insert it just after the noise texture. And by dragging these flags, we can control the contrast of the noise. Don't forget to refresh the viewport by pressing tab 2 times. What I'm going to do now is crank up the amount of details. I'm setting it to 7 and hitting tab. And now you notice that we have much more detailed representation of the noise. And as we are pushing the black flag to the right, some clipping is occurring. I think this is a pretty cool thing. We can use it to our advantage, this clipping. And what else can we do to manipulate this noise is hit Control and click on this line. So we have created yet another color thingy, and it will allow us to fine-tune the noise in a really cool way. We can also select the interpolation method. For example, switch to B-spline instead of linear, and this will make the transition between the colors more gradual, more smooth, I should say. Once we have this basic setup, we can add vector mapping node, and also hit Shift A, add input texture coordinates node. Drag the generated output over here and connect it to the vector input of the noise texture. This will allow us to control the location of the noise, to get different variation, dozens of them. Obviously, we can also adjust the scale of the noise, for example, set it to 2. It will mean the smaller features of the landscape, or vice versa, let's set it to 0.5, for example. And ta-da, we have a bigger, more pronounced features. And oh my goodness, it's so convenient to generate the look of the geometry using the material nodes. Blender developers, thank you so much. And let's try yet another feature. I have duplicated the noise and plugged it into the distortion socket of the previous noise texture. Okay, and let's add another color ramp. And by manipulating this color ramp, we can manipulate the distortion. Very small touch, but it goes a long way. And of course, you can imagine a lot more things that you can do using this simple technique. And by the way, we don't need these nodes because these nodes are pretty much the same. What I'm doing here is I'm tweaking the mapping and I'm hoping to get a brilliant result and share it on Twitter, get a lot of retweets. Okay, let's talk about bump. Go Shift A, vector bump, and drag this right into the height input. and hook it up to the normal input of the diffuse shader. We're good to go now. We can start experimenting with the strength of the bump. For example, let's set it to 2. I created this helpful little picture to illustrate how displacement interacts with bump. So what we can say just by looking at this picture is that bump is very important. Yeah, it's very important, especially if the subdivision rate is higher, like 7 pixels. So the high frequency details from the bump map kind of complement the large scale details created by the displacement. Let's move on to the next one. Ta-da! Number 3, generative modeling. I love how it sounds. Maybe it's not exactly generative modeling. Okay guys, so I created this cube and I press tab to enter the edit mode. Now I'm pressing W and selecting subdivide smooth. After that I'm pressing T to open the tool shelf and I'm smoothing it out. So you may ask, why not sphere? The subdivided cube has a much better, much even topology. That's why, and I'm really now following the routine steps. I'm adding the subdivision surface modifier, setting it to the adaptive mode. Now I'm coming over to the materials tab, creating the new material, opening the node editor, all that stuff that we do 1,000 times a day. And it's so boring, but nothing we can do here. We just have to repeat some things over and over again. That's how it works. Okay, I'm gonna add the Voronoi texture this time to demonstrate how we can manipulate the large scale details on the object. In other words, the basic shape of the object. Let's tweak the scale of the Voronoi noise. Let's start with 2. And of course, let's enable the true displacement in the material settings. To see the difference and to really start modeling, let's also add the math node and set it to multiply. Usual business as well. Let's add it, drop it over here to multiply and click and drag or just set the value. Now press tab 2 times. The object has taken a stone-like shape. We can make its features even sharper. For example, let's set the value to 7 and add the subtract node, set it to 3.5. Yeah, the half of 7, 3.5. This is not arbitrary, of course, we can do without the subtract node, but this helps to keep the volume of the displaced object and the original object roughly the same. And now I'm pressing the S key and the Z key to scale the stone on the Z axis. And I'm doing the same for the X axis. You can squeeze it and push it and do whatever you like with this shape. Of course, if you are using the procedural noise to model, this doesn't mean that you cannot use the other techniques. And I'm fascinated by how quick we can experiment with the shape. For example, let's set the scale to 3 and bam, this is a whole different story. Think about it, just by playing with the procedural 3D noises, we can shape our object. Previously, before Blender 2.78, we could play with the displacement modifier, but this stuff is really much better. Alright, I created the mapping node and the texture coordinate node. And look at this. We can tweak one value, like the X location, and we have a different kind of object instantly. We can take it a little bit further by combining the different noises. Let's add the mix RGB node. And let's also add the noise texture. And connect it to the second socket of the mix RGB node. Also, I'm gonna add the color ramp, and for now, just to preview the second socket, I'm gonna set the factor to 1. Next, I'm going to create some crazy variation by adding a few different color stops by holding Control and clicking. I'm not aiming for some particular results, so I'm just randomly setting the contrasted colors. And after I'm satisfied with the result, I'm setting the mix mode to the add. Like I said before, now we just have to press tab 2 times to refresh the calculations. And this, I think, looks pretty good. This is a pretty good base for the stone or for the asteroid or for the sponge. I don't know. Let's set also the subdivision rate, the preview rate to 1, as well as the render rate. This means that the polygon size will equal the pixel size. And this, I should say, this is a pretty detailed representation of the displacement, isn't it? You can use these displacement techniques for creating awesome asteroids and many different things. And if you want to explore kind of a different side of the force, the displacement modifier, you can watch Procedural Asteroids chapter from Space VFX. Very similar workflow, but has very notable differences. Like the dark side of the force has some notable differences from the light side. Well, alright. The next way to use the micropolygon displacement is obviously to add the surface details. In previous example, we talked about the large scale details, and in this one it will be rather medium scale or even high frequency details. Okay, so as usual we have this subdivided sphere here. We can create it by adding the cube, pressing tab to enter the edit mode, W, and then subdivide smooth a few times, or alternatively by adding the subdivision surface modifier and applying it. Literally, we have thousands of ways to create subdivided cube in Blender. One of the greatest features of Blender. Let's enter the rendered viewport mode and start the displacement ball rolling. Let's get to the node editor. Press Shift A, select texture, image texture. I've prepared a couple of seamless textures in advance. I will show it to you in a moment. Let's hit open, navigate to the folder with the textures, and let's hit this preview icon. And now we see the little thumbnails. We have lunar displacement and a lunar bump. These textures are seamless, so if you're gonna tile it, you won't notice the seam. Surprise! I'd like to emphasize that this is crucial to have seamless textures before you will apply it as the details, as the displacement details, because otherwise the ugly things may happen. Let's hit open, and if you have the node renderer enabled, now you can hold Ctrl-Shift and click on the node to preview this node. Often it's so much more convenient to work with isolated one node than to try to distinguish what it does by looking at the spaghetti monster material and so on. So it's much more convenient. Let's add now the texture coordinates node and the mapping node. Connect the generated output over here, and this one goes into the vector socket. The texture now looks like it's projected from one direction. Let's turn the box projection on. Spherical projection won't work anyway. You enabled the box projection mode, but these seams are not from our texture. These seams are from the box projection itself. Even if we increase the scale, we still see the seams. Fortunately, we can just increase this blend parameter and the seams are gone. That's also why we needed to have the seamless textures, because when we slide texture like this or increase its scale, the seams will inevitably appear. Now we can hold Ctrl-Shift and click on the diffuse node and connect the image texture to the displacement input. Hit tab 2 times and the planet starts to look pretty small, like a planetoid or even a spherical asteroid. That doesn't bother me at all. Let's add the math node. Set it to multiply as usual, just because we want to control the strength of the displacement. And if you set it very high, it will get completely messed up and look very, very small. Let's keep it kind of balanced. I'm gonna set it to 1.2, something like that. And to reduce the balloon effect, I'm gonna also add the math node, set it to subtract. And 0.6 will work. Why? Because it's a half of 1.2. I'm not even sure if it matters though. After we have finished with the displacement part, we can enhance it with the bump or with the normal map. Hit Shift A, vector bump. Connect the image texture into the height input. And connect the normal to the normal input of the diffuse shader. Now what we can do is try increasing the distance of the effect, but this looks a bit over the top for me. I'm gonna set it to something like 0.2. You can mute the node and enable it back by pressing M. And the difference will become completely evident if you zoom in a bit. Now you can really appreciate the bump details, I hope. Aren't you? And don't forget to refresh the calculations of the displacement by pressing Tab and Tab again. And I think this is just a temporary feature. I suppose that in some next version of Blender, the displacement will be updating automatically. This will be even more convenient. And someday, all the tessellation will be completely real-time, like it happens now in Unreal Engine, for example. Yay for real-time stuff! Alright, now I'm gonna show you a cool trick. Let's add the Mix RGB node right after the image texture. And duplicate all these nodes, connect it to the second socket. Now let's click on the scale and drag it down and stretch it all the way to the right. This will really increase the scale of the texture. Let's set it to 3 just to round it up. Let's get in closer. Now we can really see the difference, I hope. What we can do to add this bump map details to our initial texture is just set the mix mode to add. Goodness gracious, so many surprises in this tutorial. This is simply unbelievable. In some cases you may want to use the multiply mode, but not today. So let's get back to add mode. Lower a bit the strength of the effect, let's set it to 0.3. This is one very small but very handsome space ball made using Micropolygon Displacement. You can learn more about this planet in the Space VFX Elements update, but for now let's take a look at how we can optimize this for close-up shots, because memory problem when using displacement can be very serious. For example, if we zoom into the surface of this thing and try to render it out, we'll get into trouble very fast. Faster than we can say Blender. Technically now the camera view encompasses just a little chunk of this planet, but the adaptive displacement algorithm will subdivide the whole planet anyway. So if we set the subdivision rate, for example, to 1 and try to render it out, by the way, the resolution is 1920 by 1080 pixels. So we'll get this dreadful error. It says out of memory, bam, we're done. One thing that we can do to overcome this limitation is to use the CPU compute instead of GPU compute. If you decide to follow this route, don't forget to go into the Performance tab and set the tile size to 32 or to 64, the lower number. But that is a pathetic way to deal with this problem. Let's do it like the real nerds. Go back to the solid viewport mode by pressing Alt-Z. Now let's jump over to the modifiers tab. What I'm going to do next is add the mask modifier. What this modifier does, it allows us to hide the part of the model based on the vertex group selection. Let's come over to this tab and add a new vertex group by pressing the plus icon. Call it a mask, for example. Usually I insert some kind of joke here about Elton John or whatever. Go to the modifiers tab and select this mask as a vertex group. You can invert it by pressing this icon, but I won't do it now. Let's just press tab in the viewport to enter the edit mode. And obviously we have to have these objects selected before doing it. Now I'm pressing the C key for the brush selection and selecting these polygons. Basically these are the polygons seen by the camera. Also I'm gonna hit Z to see the wireframe and select these polygons as well. And when we have these polygons selected, we can maybe deselect the unneeded polygons by hitting Alt and dragging. The selection looks pretty good to me. Now let's go to the Object Data tab and hit this Assign button. This means that now these polygons have the weight of 1. We assign these polygons to the masked vertex group and assign the weight of 1 to these vertices. Now we have to move the masks to the top of the modifier stack. And voila, this is quick and dirty and cheap hack that will allow us to render this chunk of the planet efficiently. Let's hit the render button now, and hopefully you have enough video memory to render it without a hitch. And still, after we render it out, you can see that it took 170 megabytes at Dyson Rate 1, but it's totally worth it. Once again, often it's better not to push the displacement to simulate the smallest of the details. Use it for the overall shape and do the rest with the bump map and other textures. Alright space trollers, I hope you enjoyed the process. In this tutorial we have covered 4 ways to use Micropolygon Displacement in Blender. Terrain height maps exported from World Machine, Procedural Terrain, Generative, Modeling. Just imagine what kind of cosmic bodies you can create. Also we just scratched the surface of this planet. In the part 2 of this tutorial we'll take a look at even more fun stuff like this doodle. So 5 more displacement tips to go. Stay tuned to the other tutorials from the Space VFX Elements Free Update by Aidy Burrows from cgmasters.net and me, Gleb Alexandrov from creativeshrimp.com. Take your space art to the next level.